Hello ladies and gentlemen, I'm Ratih Puspadini from Master Informatic Engineering at University of Sumatra Utara. Previously, I was grateful for the implementation of the International Conference on Mechanical, Electronic, Computer, and Industrial Technology MECnIT 2020 and for accepting and allowing me to present my research results. The title of the paper that I propose for this activity is Future Selection on K-near Neckboard Algorithm using Similarity Measure. Well, the outline in my research is divided into several sections including Part 1, Background of Research, Part 2, Objective of Research, Part 3, Method and Data of Research, Part 4, Results and Discussion, Part 5, Conclusion and Recommendation. Background data is often frequently abstract or difficult to understand and sometimes has large dimensions. So it is very difficult to know the message or the meaning of the data in data mining. It can be processed by using some methods so it can be easier to understand. The methods are such as machine learning and neural network are a branch of the data mining processing that popular is used because have the good accuracy in the data processing. The methods of machine learning are often used in data processing because computation simplicity is K-nearest neckboard. KNN can be used in some cases such as prediction or classification of diseases by good accuracy. The KNN method in implementation is very simple in computation processing and no need difficult training processing. Furthermore, available some weakness of the KNN, such as vulnerable in data high dimensionality. It is because the data high dimensionality, so space can be occupied in instance too bigger. Therefore, it can be near to neckboard in the instance is not close at all. To solve the problems are needed a technique that is known by feature selection. It is method to omit some attribute or variable from data that is considered to have data redundant or data mismatch, so must be omitted. Objective research. This research will be applied to feature selection technique using a similarity measure. Each feature will see its resemblance to the data class. Features that do not have a resemblance to the data class will be selected or omitted because they are irrelevant. The technique used to see the similarity of features with the data class, namely Euclidean distance, correlation distance, and quotient similarity. The test selection of the features in the study involved 3 different datasets. Furthermore, it will be calculate result of the average accuracy of classification data using the KNN algorithm without the feature selection process with the KNN accuracy result with the selection of feature using similarity measure, Euclidean distance, correlation distance, and cosine similarity. Testing each method will be performed and compared to be able to see which method of resemblance is good and provide optimal results in eliminating features of irrelevant data on the KNN algorithm. Method and data of research. Step 1. Normalizing input data for the input value of input. The KNN algorithm with no feature selection will be calculated for the accuracy of data classification for comparison of proposed feature selection method. Step 2. Calculate the level of resemblance to the first to nth feature with the target data using the similarity measure method, Euclidean distance, correlation distance, and cosine similarity. Step 3. Distance gain similarity will be sorted from lowest to highest to get several features to be selected. If the lowest obtained value will be eliminated because the feature is irrelevant or no effect on the data classification. Step 4. The result of the selected feature will be classified by the KNN method. Step 5. The accuracy result of the proposed method. The study used 3 different test datasets. Thus, obtain the best accuracy of each algorithm. The 3 specification datasets to be tested are obtained from the internet page UC dataset. It's as follows. Dataset 1, High Time Resolution Universe, HTRU2. Dataset 2, Diabetic Retinopathy Depression. Dataset 3, Default of Credit Card Clients. 3 datasets will be initialized based on the number of data dimensions to make it easier to test the 1, 2, and 3 datasets. The result of KNN with Euclidean distance testing. This testing process is done by comparing the data classification result between the KNN algorithm and the KNN selection feature. The selection of feature used the Euclidean distance equation done by comparing distance or similarity between feature with the data class. Data classification test result with KNN algorithm after the selection of feature with Euclidean distance is as follows in the table. The result improved accuracy selection feature occurred after the addition of the algorithm Euclidean distance for the processing of test datasets, namely, dataset 1 is 98.508%, which increased by 0.044%. Dataset 2 is 82.189%, which increased by 0.782%. Dataset 3 is 86.663%, which increased by 0.123%. The results of KNN with correlation distance testing. The second testing was done by calculating the accuracy of the feature selection with correlation distance. Between feature and data class will be selected with the smallest distance or resemblance, and then the feature selection process will be performed. Data classification test result with the KNN algorithm. The feature selection of correlation distance is as follow in the table. The results improve accuracy selection of feature with correlation distance for the processing of test dataset, namely, dataset 1 is 98.508%, 464% equal to no selection. Dataset 2 is 83.579%, which increased by 2.172%. Dataset 3 is 86.657%, which increased by 0.117%. The results of KNN with cosine similarity testing. The third result testing is done with the selection of features using cosine similarity. Features that have a minimum similarity value will be eliminated because the data is considered irrelevant and has no effect in data classification using the KNN algorithm. The results of the feature selection accuracy are as follows in the table. The results improve accuracy selection of features with cosine similarity for the processing of test datasets. Namely, dataset 1 is 98.497%, which increased by 0.033%. Dataset 2 is 82.189%, which increased by 0.782%. Dataset 3 is 86.717%, which increased by 0.177%. Based on the test result above, that the selection of features in the KNN algorithm using similarity measure, Euclidean distance, correlation distance, and cosine similarity, with all three test datasets, experience a not much difference accuracy improvement. It is proof that the three proposed methods for the selection of features on the KNN algorithm succeeded in reducing or eliminating the feature by not experiencing decreased accuracy. Accuracy after the addition of the selection of feature increases very small, but still able to extend the irrelevant features inside the dataset. And some contribute that the proposed method is capable of eliminating irrelevant features inside the dataset by not lowering the accuracy of the previous data classification. The test results are shown in table as follows. Feature selection method KNN, average of accuracy 80.84%. Feature selection method KNN with Euclidean distance, average of accuracy 89.12%. KNN with correlation distance, average of accuracy 89.56%. KNN with cosine similarity, average accuracy 89.13%. Conclusion and recommendation. Based on the testing result above, that the selection of features in the KNN algorithm use similarity measures, Euclidean distance, correlation distance, and cosine similarity, with all three test datasets experiencing improved accuracy. The average selection accuracy feature with the KNN algorithm of the three datasets tested was 80.84%. The KNN with Euclidean distance was 89.12%. The KNN with correlation distance was 89.56%. and the kind M with cosine similarity was 89.13%. This research gives some contributes that the proposed method is capable of eliminating irrelevant features inside the dataset by not lowering the accuracy of the previous data classification. The recommendation given in this study need to do optimization with other methods such as genetic algorithms or B-colony optimization. This is because there are many combinations of features selected that get different results. The feature selection results using the similarity distance measures method can be used as the initial population in genetic algorithms to obtain better selection results. Thus, the results of the presentation that I can convey and thank the committee and reviewer of the International Conference on Mechanical Electronics, Computer and Industrial Technology, MECnIT 2020, which have helped me a lot in perfecting the contents of my research. I hope this research can be a reference for other researchers so they can get better results.